right, so good morning. So this is session one of 2 sessions. This morning we're going to go over unified namespace, some foundational stuff. It's going to be a theoretical lesson. And then at 1 o'clock this afternoon, I'm going to integrate WinCC OA into an existing unified namespace. And the approach we're going to take this afternoon is we're trying to figure out how to get adoption of WinCC OA in the EU, increase the adoption of WinCC OA as an IIoT platform, and in North America, just to get people to use it in North America. I've been talking about WinCC OA since like 2018. I used to say the 2 IoT platforms I use are Ignition and WinCC OA, and I've been saying that in our videos since 2018. And yet adoption of WinCC OA has not increased in North America at all in that time. Primarily because it's hard to it's hard to get WinCC OA. Like, it's hard to download it. It's because of German export laws. So for those of you who are Germans, start yelling at your politicians. If you want people to use your products outside of Germany, it's got to be easier to use them. It's really impossible. I have people's phone numbers. I have like all the most important people at WinCC OA. I have their emails and phone numbers, and for me it was hard. I tested starting Sunday. It took a day and a half, right, to get the links, and then it was 14 minutes for install, right? So if it took a day and a half for me, a guy who has Lucas's email and phone number and Sophian's email and phone number, and if it's a day and a half for me, then it's going to be at least 3 days. It could be forever. It could be a really long time. So our goal, my goal coming here is, how do we get more people to use WinCC OA as an IIoT platform in the European Union and not use it as SCADA Plus? Because that's a really, it's really underutilizing the power of the platform if you're just using it as SCADA Plus. And then in North America, how do we get people to use WinCC OA more? Because WinCC OA has really, really unique competitive advantages around robustness. I mean, you can build enormous systems in one instance of WinCC OA. Throughput, data throughput and data volume on a single WinCC OA instance is about almost 10x the next closest platform. Okay, it's incredibly, incredibly powerful. So what I want to talk about this morning, I'm going to talk about unified namespace. Okay, so that everybody who's watching at 1 o'clock, who's in the 1 o'clock session, we all have the same baseline. Okay, and then at 1 o'clock, I'm basically going to show a lesson, an application that we're going to share on GitHub that anybody can download and use, and you'll be able to take WinCC OA, bolt it onto an existing unified namespace, import all the topics as data types and data points inside of a WinCC OA application, and then use Node-RED inside of WinCC OA to do data operations, and then use Node-RED as the egress. The reason I've chosen to use Node-RED is because I won't have to teach anybody Node-RED. So in North America, if I'm trying to get people to adopt WinCC OA, the learning curve is kind of high unless you're a software developer. So we want it to be a faster adoption rate. So by using Node-RED, I don't have to teach anyone egress at all. All I got to do is teach them how to download it, install it, create a legacy project, then use the MQTT Explorer to connect to an existing UNS, consume all those topics in, generate the data types and the data points, and then go to Node-RED and do data operations, and then egress back out to the UNS, which is what we're going to do this afternoon. Okay? All right, so for those of you that are in here, just so I like to know who I'm talking to. So how many of you are engineers? So most of the room, software developers, engineers and software developers, salespeople. Okay. If you're a salesperson, do you have an engineering background? Okay, good. And then any executives? All right. How many have heard of unified namespace? Okay. How many are using unified namespace as an architecture? Okay. All right. If you've heard of unified namespace as an architecture, but you're not using it, why aren't you using it? You can just yell it out. What's that?
Unknown.
It's unknown? Okay. I'm going to talk about where unified namespace come from, but before I do, I didn't do this yesterday and I was supposed to do it. I got yelled at by the team for not pointing this out. So the reason I'm here, the reason I was invited to come speak in Prague is because in 2018, we started shooting YouTube content on Industry 4. I'm going to talk a little bit about my background and kind of how I even got to where I am right now. Okay, why is it, you know, the Siemens guys and the ETM guys invited me to come here and speak. Why would they invite me as opposed to somebody else? I'm going to talk about that. But 2018, if you don't watch our YouTube content, we started shooting YouTube videos in 2018. As the story goes, Zach Scriven, who is my right-hand man, he's also on the YouTube content. Zach is a very gifted engineer and software developer. He worked on the project with me where I won my Firebrand Award. So I'm the only engineer to win back-to-back Firebrand Awards in North America. In fact, I'm the only person to win it twice. A Firebrand Award is kind of like the Nobel Prize in North America for engineering. Like once you win a Firebrand Award, everybody wants you to be the lead on their project. So I won a Firebrand Award in 2012 and 2013 using unified namespace. I talked about the project the big one that everyone started hiring me for. That was for Pioneer Natural Resources that was recently purchased by ExxonMobil. If you want to look at the impact of digital transformation on Pioneer Resources, go ahead and take a look at their stock price from 2014 until 2023 when they were acquired. It more than doubled. Okay, and then they were acquired by Exxon. If you look at their stock price prior to 2014 and you go back the previous 15 years, it was flatlined. Okay, so that was digital transformation, and that project I talked about is what fundamentally transformed their organization and led to a huge acquisition by Exxon. So 12 and 13, I won back-to-back Firebrand Awards, and then I started my own systems integrator, and a bunch of engineers came to work for me in 2015. And in 2018, we had sort of developed the reputation of we're the integrator who can come in and solve failed digital transformation. So what was happening was like Deloitte would do a big project, or Capgemini would do a big project, or Wipro would do a big project. All the big integrators, they would start these huge enterprise digital transformation initiatives. The clients would get 18 to 24 months in, and by that time, you could rip a customer off for 18 months easy as an integrator. They would have no fucking idea, because it's the 80-20 rule, right? I mean, you get 80% of the deliverable in the last 20% of the work. So you get 80% into the budget before they ever realize they got ripped off. And that happens all the time. So we developed a reputation of being the integrator you could call to come in and fix that problem. Well, the problem is my engineers got tired of that. Okay, so I was really worried about turnover. I had an elite team and I was really afraid that the team was going to leave. So Zach Scriven, who worked on the Pioneer Natural Resources project, he left engineering. He got sick of it and he started a digital media company called Zach Scriven Media. And he asked me if I'd be his first sponsor of his podcast. I said, sure. It was like $500 and I paid him $500 and I was on the podcast. And then I wanted to help him out. He's like a little brother to me. So I was like, hey man, why don't I hire your company and you'll do digital media for us? This is like in 2017. And I go to the board of directors and we get $5,000 a month approved. And Zach flies out from Phoenix every month and he's shooting videos, interviewing the engineers. We have no idea what we're doing, But the deal was I would not be on camera. Contrary to popular belief, I do not like being up here in front of everybody, and I do not like being on camera. I hate it. Okay, I do not like it. You guys may have noticed I left the dinner early yesterday. I always do that. The team comes with me because I'm an introvert. I actually am not an extroverted person. This is a skill that I've learned because I think it's important. Okay, but I don't enjoy being up here or being on camera at all. So for 6 months, Zach was filming and nobody was watching the videos and no one was clicking on the LinkedIn posts. And my board of directors after 6 months said, hey, we're not, we've spent $30,000 so far and we haven't seen any return. You get one more month. And I told Zach that. And so Zach just took it upon himself. This is part of the reason he's on our team. He goes rogue from time to time. And he set up a whiteboard video. It's one of these right here, where I'm wearing that. So the videos where I'm wearing that yellow, my hair's not done and I'm not wearing a mic, he tricked me. So that series, that's from 2018. He said, hey, our video editor is in the Philippines and he doesn't understand what we do. And I'm famous, I'm famous for being a whiteboard guy with our team. I teach on the whiteboard. So he said, I'm gonna bring you out here and I'm gonna ask you 4 questions. You're gonna answer the question for the video editor. And you're gonna teach him what it is we do. And then he said, what is IIoT? And I'm thinking I'm talking to one guy in the Philippines. And then he says, what is Industry 4? What is MQTT? And I don't remember what the last one was. And then he posted that on LinkedIn that Friday night, and it went viral over the weekend, and it got like 100,000 impressions. And then that was when we realized, oh, education is what's missing. So what we've been doing is educating since 2018. That's what we've been doing. I've just taken everything I've learned over the course of my career, and I just teach it, for better or worse, okay? So if you're not familiar, if you want to know why it is we started doing YouTube content, it's because I didn't want to lose my engineers, and Zach tricked me. That's how I ended up doing this. 2 years later, though, I will tell you, for those business owners out there, or those of you who want to go into business for yourself one day, was an incredibly important step for us, and we had no idea that it would turn into what it turned into. In 2018, when we shot the first videos, 1/3 of our business came from vendors. We were channel partners. 1/3 of our business came from existing customers who referred us to other customers, and 1/3 of our business came from our existing customers. We just did more projects with them. When I sold Intellic Integration in September of last year, 100% of the business is inbound. It is people calling Intellic Integration and saying, we want you to do our project. Okay? This played a huge role. I had no idea that this would turn into what it's turned into. I had no idea. It was not part of my plan. Okay? We did end up putting it down on paper. We tried to figure out, like, how did this happen? And we put it down on paper. And this isn't part of the lesson, but I think it's important. You know, yesterday, I intentionally tried to piss off the room. That was conscious. Like, I intentionally tried to get people to want to prove me wrong. That's the reason I used the attitude I did in the room yesterday. That's called conflict theory. Okay, and it works very well with engineers. So because engineers oftentimes are very passive aggressive. You have hardcore type A's and you have B minuses in terms of personalities. So what I will do is I will say something inflammatory and I'll know I have the facts right. And if I'm just up here being really nice and I'm like trying to be your buddy and I make some statement and I'm using Carnegie's strategies on you, how to win friends and influence people, I may not have the ability to challenge you to think. But if I say something that you disagree with and I piss you off so much when I do it, and your entire goal is to prove me wrong, I can compel you to confirm that I was right. And you learned something. And the guy who challenged me on the Tesla thing yesterday, he learned something. He did learn the data on BMW and Audi. And he learned it much faster than he would have learned it if we just tried to have a cordial discussion sitting at a table out there in the hallway. He confirmed it himself in the room, okay? The reason I bring that up is that approach has played an incredibly important role in my career. Yesterday I had a meeting with Bernard and Lucas and Roland, and so Roland's an executive at Siemens, and Bernard is the CEO of ETM, which was in WinCC OA, and we're trying to figure out how to expand the reach of WinCC OA in North America, right? Here is a challenge I run into in the European Union. Okay, I don't want to offend anybody who's European. I love Europe. Okay, but Europeans are way too agreeable. I often find that it's very hard. If I'm giving this speech in the United States, there's going to be 24 engineers arguing with me. Like we're going to be having a spirited debate about the stuff that I'm going to show you guys. I can come here and everyone will shut the fuck up. I mean, they'll go have a beer and be mad about it, but they won't engage directly, right? And I'm going to say something you guys don't want to hear. The European Union is in a lot of trouble. A lot of trouble. Like, I cannot overstate how much trouble the EU is in. Okay? It is basic math. It is simple math. All right? We have a data set of 2,000 manufacturing and industrial customers all over the world. Okay? They've been scored across 10 industry 4 pillars. 2,000 companies. All right? Of the 2,000 companies, 400 of those are based in Europe. When we do the normalized distribution and we measure those companies on digital maturity across 10 industry 4 pillars, guess where the European Union falls among 4 key regions in the world? Dead last. Dead last. And I know that that's probably a shock to you guys. Can you explain why? Primarily strategy. So strategy is one of the key pillars. There is no reason for making data the primary commodity. So when you ask executive leaders, when you ask the executive leadership, what is your strategy for data? The answer is always to protect it. Okay? If I go to Tesla, I'm going to use Tesla, and I can mention Tesla, which is why I use them all the time. They're one of my customers I can mention. If I go to Tesla and I ask them, what's your strategy for data? What do they say? To commoditize it. But if you say in Europe, what is your strategy for data? The first response is to protect it. That's not the purpose of data. Data is a commodity. It's a commodity. It is not an asset. It is not an asset to be protected. It is a commodity to be packaged and sold. Okay? And that's the key reason, is that without lacking that strategy, it's not technical know-how. In fact, across those 10 pillars, when you look at the workforce is the most technically fluent in the world of the 4 key regions. They have the most technically fluent, even higher than North America, technically fluent, but the worst strategies, with the exception of, what's the guy's name at Volkswagen again?
Oliver Bloom.
Yeah, Oliver Bloom. Unfortunately, no one's listening to Oliver Bloom. Okay. All right. The reason I bring up conflict theory, I want to talk about my career real quick and where unified namespace came from, because I think this is important. I grew up in, since y'all aren't from the United States, I grew up in North America, or I grew up in the northeastern United States in the 1980s. I'm 51. I was born in 74. I cut my teeth at a time when manufacturing was leaving the region that I grew up in. It used to be an industrial hub, and then all the manufacturers left in the 80s and the early 90s, and it decimated the communities. So I got to see with my own eyes what a weak industry and a weak manufacturing sector does to communities. It basically decimates the middle class, and then it compels governments to try and subsidize middle class lifestyles by borrowing from the future in order to pay for today. Okay, and now we're suffering those decisions today. That's why we have 30 trillion in debt in the United States. I went to school in North Carolina studying sociology and history originally. When I was a little kid, I believed that the reason manufacturing left was the reason most people believed. It was greed. Somebody said it yesterday, cheap labor, right? That actually isn't what happened. Cheap labor was a means to an end. I talked yesterday about in 1969 when the PLC came out, okay? Germany and Japan were the first 2 nations to adopt PLCs, okay? Japan was ahead of everybody. And the Japanese auto market was crushing the American auto market in the early 1980s, and that's what led to Chrysler's bankruptcy. Okay? American companies didn't adopt that technology at the beginning of the third industrial revolution. American companies didn't adopt it. They didn't start adopting until the mid 80s. But by that point, they were so far behind, they had a stopgap they needed, which was they went to Mexico, they went to China, they went to Vietnam for cheap labor to stay in business while they tried to leverage technology to be more competitive in the market. So I learned in college, oh wait, the issue wasn't that CEOs are greedy. I hate to break the news to you. I talk to CEOs all the time. And are some of them scumbags? Absolutely. I mean, some of them are complete psychopaths who don't empathize with anybody, but that's the exception, that's not the rule. The vast majority of executives genuinely and truly care about all the people who report to them. And they take it as a personal, moral responsibility that their well-being is in their hands. That is the vast majority of executives, okay? So it wasn't greed that caused that. It was a lack of adoption of technology early enough to remain competitive. You're gonna see a pattern here, okay? So right out of college, I started working in a salt mine, shoveling belts. I had a degree in sociology. I was not an engineer yet. I was shoveling belts. And I had a 5-volt DC certification that helped me, that I learned how to read IEC drawings when I got this 5-volt DC certification working on pinball machines when I was in college. And while I was working in that salt mine, we had a bunch of German engineered SMAG mining equipment that was all automated. We had 2 sets of equipment. We had Fletcher mining equipment, which was hydraulic over hydraulic control, no automation whatsoever, no electric on it whatsoever. And you had fully automated German mining equipment called SMAG that had PLCs on it and remote control. And nobody who worked in the salt mine that I worked in could work on it. My supervisor, Joe Rolfe, saw on my resume that I could read IEC drawings. So he put me with an electrician and he said, go with this electrician. These drawings are all IEC, which we don't use in North America generally. And he said, you're going to translate the German and you're going to help him troubleshoot this roof bolter. And it was a really simple fix in the end, but at the time it took 3 days because I didn't know 3-phase AC. I knew DC systems, that's it. After 3 days, that roof bolter had been down for a year, sitting in a reliever. And they were thinking about bringing the technicians over from Germany to fix it. That's how far behind the US was, okay? Anyway, after 3 days, I fixed it and realized, oh, I was born an engineer. So I went back to school and got a double E. I became an electrical engineer, and that's when I learned, oh, this is how I can help save and create middle-class jobs in the United States. Because one of the things I learned in college was that the industrial revolutions, those are natural phenomenon in any civilization. That they're not unique to what happened to it. The zero industrial revolution is going to happen always, always, always. The first industrial revolution will always happen. The second will always happen. The third will always happen. The fourth will always happen. And Moore's law says that each iteration will take half as long as the previous one. So you notice if we look at these industrial revolutions, 1712 steam engine, 1913 assembly line, 1969 PLC, 98 TCP/IP, 2022 ChatGPT, each iteration takes less time because we get smarter as human beings. Anyway, right around 1998, when the fourth industrial revolution began, that's when I was introduced to industrial controls and realized how I could help save and create middle-class jobs. So fast forward, I'm working in the mine, and we have all PLC-controlled conveyors underground. We're using Data Highway Plus is our serial communications protocol. We have a couple of ControlLogix PLCs, and we have a couple of instances of RS Links. And nobody in the mine, our mine was 7 miles. This is underneath a lake. It was 7 miles from one end to the other, and the speed limit was 15 miles an hour. And if a conveyor went down, the entire operation stopped. Everyone just stopped working until somebody found out which E-stop was down. Because something fell off the roof and hit a cable and shut the conveyor down. So I decided I have to have a single source of truth. I have to have one pane of glass that shows the current state of our entire operation. I have to figure out how to do that. And then I have to make it so that it's distributed so that I can give the supervisors on their laptops something they can look at to look at current state. So I looked at all the prevailing technology and I was like, hey, I can use Microsoft Excel. We got DCOM on the laptop. I can use Microsoft Excel. I can use COM or DCOM, and I can use Dynamic Data Exchange from RS Links, and I can essentially create a semantic hierarchy of our mine and show the state of all our conveyors. And I can have them view the spreadsheet on my laptop using Dynamic Data Exchange. I can create a spreadsheet for that supervisor that will reference the cell inside of my broker, which was Excel. The first unified namespace was created in 2005 in a mine in upstate New York on an Excel spreadsheet. And then I went to printing right after that, and I built a UNS in printing, single source of truth, single pane of glass. Every person in the operation could look at current state in real time. And then I went to Nucor Steel, and I did the same thing in a steel mill. And then I went to Tier 1 Automotive, and then I became a consultant. And between 2008 and 2014, we attempted to use OPC UA as the IIoT protocol for unified namespace. And if you will notice, I'm very hard on OPC in my videos. It is not because I don't know OPC UA inside and out. I do. I assure you, there's nobody in this room who knows the OPC standard better than me. I've met two people on the planet who know it better than me. Matt Paris is one of them, and Eric Barnstead is the other. There are two people. OPC UA is not an effective IoT protocol, so I had to find something else. And that was when I was introduced to MQTT, also AMQP by Microsoft, and DNP3, which is primarily used in the energy industry. You'll notice the commonality of those three protocols is they're edge-driven, so the client reports in, they report by exception, and they're lightweight. Okay? All right. I become a systems integrator. We win a couple of awards. I make a really successful company, and then we start educating in 2018. And since 2020, we've been teaching at IIoT.University. The lesson I'm going to go through today is a lesson I've done many, many times at IIoT.University. Okay? And we're going to start with what is unified namespace? Okay? Because this is what we're going to be bolting into this afternoon. So you'll remember, somebody's keeping track of the time, right? How long have I babbled so far?
27 minutes.
All right, good. Plenty of time. So what you'll notice is all unified namespace is an architecture that is a single source of truth in a business. It's not system of ownership. It is a single source of truth for current state. It's semantically organized, okay, like the business. So think of it as like a file share. When you go to work for a new employer and they have a file share, excuse me, and you're navigating through a file server to try and find the documents that you need, the spreadsheets that you're supposed to fill out or whatever, they are semantically organized in a way that makes sense to you so you can find those documents, okay? That's what semantic hierarchy is. The semantic hierarchy we use is ISA 95 Part 2. So all businesses are organized the same way. By the way, why is it ISA 95 Part 2? Does anybody know why? Enterprise site, area line cell. Does anybody know why every business organizes themselves enterprise site, area line cell? Yeah, the ERP systems, yeah, the master data models inside of ERP systems use ISA 95 Part 2. So they organize the business the way the ERP system enforces them to, okay? And then the business unit is not a semantic level, it is an attribute of a semantic level, okay? So a lot of people will go, well, what if I have business units? Well, it's not enterprise business unit site, it's enterprise site with business unit being a parameter of the site, okay? All right, so we semantically organize data, okay? All of you become clients, all of you become nodes in an ecosystem, and you publish your data to me, which is a unified namespace, okay? And you're given a location to publish into. You also can subscribe to anyone else's data. Okay, so if we know how it's organized and we know where it is, then and it's semantically organized, that means it makes sense, then you'll be able to go and look up anything, any data you would need to do your job. What are the two, when we do these assessments, when you know how I told you we do we scored 2,000 companies across 10 pillars, there's a whole methodology we use. And it starts with, we have these meetings with 5 key groups in every organization. So whether we're talking Coca-Cola or whether we're talking Bob's Crawfish Peeling Shack, we do it the exact same way. We meet with the executive leadership, we meet with operations, we meet with maintenance and engineering, we meet with quality, we meet with IT. And we're really asking them 3 questions. They're 90-minute meetings, but we're asking them, what are you good at, what are you bad at, and what's missing? We're trying to distill everything down into those 3 questions. What are you good at? What are you bad at? What's missing? We're trying to get the executives to articulate to us what their digital strategy is. Surprisingly, very few companies, very, very few companies know why it is they would want to commoditize their data. Very few, okay? I mean, and I want to stress this. Yesterday, everybody here is really smart, really educated, very technically adept, right? Every person here. And I'll bet very few of you realized until yesterday that Tesla was selling sensors. Okay? Elon has known they were selling sensors since 2012. And everybody who works at Tesla knows that that's what they're selling. They're selling a sensor. They're not selling a car. The car is just the vessel. That's all it is. So there are leaders out there. Bezos. In 2002, Jeff Bezos, you ever read this famous email that Bezos sent? 2002? Where Amazon Web Services came from? In 2002, Jeff...
API principles.
Right. He sent an email at 2 o'clock in the morning. He just had this epiphany. He's like, I am sick of people sending data through email. I'm sick of the spreadsheets. I'm sick of people walking to the office next door to share data and information. Effective tomorrow morning at 8 a.m., you will build services. If you don't build services, you're fired. This is a zero tolerance policy. You can look the email up yourself. You don't have to trust me, okay? You can go Google Bezos' famous email 2002. That turned into Amazon Web Services. And Amazon Web Services, when you go to EC2 and spin up a VM on Amazon AWS, you are inside Amazon's infrastructure. The same infrastructure Amazon runs in. The exact same one. Same data centers, the same infrastructure. You're using the same services they use to run their business. Data as commodity. And then they took that data to predict what it is we buy 6 weeks before we buy it. Okay? But the number one reason organizations struggle is because they don't have strategy. But you want to know the 2 things that those other groups outside of the executive leadership, operations, IT, quality, and maintenance and engineering say? When you say, what do you suck at and what's missing? What do you think they say? There's only 2 answers. Every single company says the same 2 things. Go ahead. Go ahead.
Yeah, it's about not being able to get the right data to do.
Right. Access to the data they need to do their job. And number 2, insight into current state. I don't know where I am right now at all. I have no idea where we are. Where are we according to plan? Which assets are running? Which ones are down? Why are they down? Why were they down over the last 24 hours? It's the same 2 complaints. I don't have access to the data. UNS solves that. Okay? I don't have insight into current state. UNS is current state. So the next piece about unified namespace is it's the current state of the business. Now there's a higher level piece here. How many of you have been involved in machine learning applications in manufacturing? That is, you know of a manufacturer who did a machine learning. How well did that go? Okay, who here would give the success of that project a 10 out of 10? Okay, right. Because no one ever says it's 10 out of 10. Why? Why is it machine learning applications? Machine learning is trying to predict the future training on the past to monitor the present to predict the future. That's all ML is. Why, if it's that simple, like you could take the dumbest computer scientist, the dumbest data scientist, the kid who graduated absolute dead last in his class, and you could say, I want you to do linear regression between that temperature sensor, okay, and the failure of this seal, and he can write you an algorithm that will nail it to a T, 5 nines accuracy. The idiot data scientist can do that. So if it's that easy, why is it manufacturers fail? The data is low fidelity. So that is, fidelity of data is the quality of the data. What percentage of an event, of the events are reliable, okay? Low fidelity, normalization, and context.
The thing is that the future is different than the past often. So like you train on past and it's brittle. Like, you know, it doesn't generalize.
That's the problem they should be complaining about. The problem is that they're not even getting to the point where they realize their problem is that the future changes. That there are variables that we haven't trained on. They never even get to that point. Like, for example, does anybody know what normalization of data is? Okay. Does anybody not know what normalization is? Okay, so if I have a temperature sensor and an OEE calculation, and I want to find out the relationship between ambient temperature inside of my facility and the overall equipment effectiveness across all of my assets, okay? I want to train a model on that. And my temperature sensor changes 60 times per second, and my OEE calculation is done once per minute. The first thing I have to do is I have to normalize that data. So for every highest frequency transition, I have to have a AB value. The first thing I have to do is normalize it. So when you hear about data scientists having to, they scrub data or they clean data, what they're doing is normalization and context. They're throwing away the crappy stuff, they're creating the relationship, and then they're normalizing it so they can train. That's what they're doing. UNS solves normalization and it solves context. The reason UNS as an architecture, Roland asked me, is unified namespace going to, do you think it's going to win as an architecture? And the answer is, it's already won. It's already won. But UNS will continue to evolve. The reason UNS adoption has exploded over the last 2 years is because everyone who works with unified namespace says, why the hell didn't I do this a decade ago? Okay? Yeah.
Question.
Sure.
Do you know OMAC?
Say that again?
OMAC standard. OMAC
Yes.
standard.
Yes.
Which is the difference?
So OMAC is more, it's more, so OMAC is more specific. It's a much more specific standard that contains
Context, specific context.
Predefined context is a better way to describe it.
And in your case, UNS, no. You can use the ISA. You have the freedom.
A fundamental principle of UNS is that we collect and store as it is, not as it should be. We were talking about physical reality yesterday, right? A fundamental principle of unified namespace is we want to connect, collect, store data as it happened, as it is, not as it should be. Why everybody's heard the term digital thread, right? Okay. Why is Azure IoT, the original Azure IoT infrastructure, which got sunsetted 2 years ago, why did that get sunsetted? Why did it get thrown away? Does anybody know why? I mean, if you ask Clemens Vaster or Eric Barnstedt, they'll say because no one bought it. All right, so let me ask this question. Why didn't they buy it? Why did no one buy Azure IoT? What's that?
It was very not flexible. You couldn't adjust it.
It was deterministic.
Yes, you had to follow what was decided by Microsoft and not.
So digital thread is, those of you who are software developers, raise your hand again. Okay, digital thread is nothing but object orientation for physical reality. We create some object on the edge, say in the shape of a triangle. We call that a tank maybe. And then we have an API that calls the triangle. It knows specifically how that object is structured. Then we have a visualization layer, an analysis layer that is designed to process a triangle and visualize a triangle, right? The reason digital thread doesn't work in industry is because you can't completely model on the edge. As data moves up the stack, from PLC, HMI, to SCADA, to MES, to ERP, to cloud, context is added. The triangle turns into a parallelogram. It turns into a circle. It turns into a square. OEE isn't calculated on the edge. Why is it not calculated on the edge? Because standard rate isn't stored on the edge. Okay? So, and OEE is part of the context of the shape of the object. UNS is designed to overcome that. It gives us the ability to collect from the edge as it happens, and then add to it later on. We can add OEE in from a different node. Okay? UNS is an architecture that accounts for that. I'm going to go ahead and read through the definitions because they're important. So unified namespace is the structure of your business and all the events. It's a single source of truth for all data and information in the business. It's the place where the current state of the business lives. It's a hub through which the smart things in your business communicate with one another. And it's an architectural foundation. We need it so that we can scale, so that we can normalize, so that we can have short time to value. I'm going to show what I mean there. It's secure and it's agile. The security piece, this is very important. We're in the European Union. I don't care about security. I think security is something only dumb people worry about because smart people can always overcome any security. Security is a myth. It's not real. You're only as secure as the person who their desire to get your data. Locking your front door is not making you safe. Someone can break the window and just, if they really want to get into your house, they're going to break the window. If they really want to access company data, they're going to put a gun to your head and say, type in your password. Okay? So there is no such thing as security. What there is are hurdles we put up to discourage people from putting in the effort. Okay? But let's talk about the security piece. Purdue security model, everyone knows Purdue security model. Do you know it? Does anybody, is he the only one who actually knows it, or does anybody else know Purdue? Wow, you guys don't really know. Okay. Purdue is the security model you use. Okay, you just don't know it by Purdue. Okay. So Purdue is the security model that's got the DMZ above L2. Okay, that's called Purdue. Why you want to know why that exists? It exists because of client-server relationship. So if you guys are all the devices on the plant floor and I'm the thing in the cloud that wants your data, if I'm using a poll response architecture, then I have to have a hole punched in the firewall for me to request your data. But if I use edge-driven technology, edge-driven report by exception, lightweight, open architecture for unified namespace, you instantiate the connection with me. So we only have to allow you to talk out, and I can't talk in. I can only respond to the connection and request you established with me. Okay? Unified namespace is inherently secure. Okay? It overcomes a lot of the security challenges that we see with other architectures. Okay? And what does unified namespace look like? So this is a sketch of a unified namespace. Okay? And I'll show you a better example. I'll show you an actual virtual factory. But you have enterprise, site, area, line, cell. We have functional capabilities. So a functional capability could be something like OEE. It could be changeover. It could be batch fill process. You name it. It could be EBR, electronic batch record. That is a functional capability. You would create a namespace that has inputs, outputs, and intermediate variables inside that namespace. And if I had a functional capability called EPR, and it was all populated underneath that functional capability, and I was a client that could read that, I could then automatically put in the context of the EBR at current state with the top 10 downtime reasons on the production line in context just by subscribing to both of them. I can store EBR and top 10 downtime reasons just like this. Okay? So I have the data in context and I have it in real time. Okay? How is unified namespace, how is it used in practice? Here, let me zoom in here. So we're going to show connect, collect, store, analyze, visualize here. So in the upper left-hand corner, in the right-hand corner, I have a visualization that is work order information in the upper left-hand corner, OEE in the center, run and shift information in the upper right-hand corner, and the lower left-hand corner in this template, we have downtime. In the lower right-hand corner, we have the cell downtime, and then we have a menu on the left. We have a unified namespace over here on the left-hand side. The work order information is a visualization of the order information underneath the informative namespace called line overview dashboard. Okay? The run OEE is coming from production efficiency namespace with run OEE, OEE availability, quality, performance. Okay? This is just a visualization layer. It's irrelevant. When I have a unified namespace and I build my namespaces this way, the informative and functional namespaces the way I do, then how I visualize it is irrelevant. He could use Grafana on the UNS. You could use WinCC OA. You could use Tableau. It's irrelevant. As long as they meet the minimum technical requirements, they can communicate over MQTT or whatever protocol. I'm not going to talk about MQTT a lot because MQTT is not the only protocol we use. Then I can visualize it. Okay? When the client has a new problem, some problem they want to solve, like for example, we don't have changeover in here right now. And let's say what they say is they want to have a changeover state visualization. Then all I have to do is design a functional namespace that has the inputs, the outputs, and the intermediary variables and parameters. And then I build a template to view it. And then I have a tool publish the changeover in, and then I just map the changeover view to the changeover namespace. Okay, that is a very simple overview of what UNS is. That is not inclusive. So let's take a look at what unified namespace looks like over time. All right, so I'm going to run a simulator here. We will run agent demo and demo full. All right, what we're going to see here is a demo starting to populate. All right, so this is what a unified namespace looks like over time. So what's happening here is there's basically 6 phases. There's phase 1 is what does a unified namespace look like in the first 6 months? And then phase 2 is what does it look like after I've been working with a client for a year? And phase 3 is what is 18 months? And what we're seeing here is a unified namespace expand. So we started with line 1, enterprise site area line 1. We brought in the edge data, in-feed, out-feed, waste, and state, which is what we need to calculate OEE. Okay. Then we created an MES functional namespace with KPIs, and then data for quality and maintenance. All right. Then we added in some additional process data off of the process. This is coming from the PLC. And then we brought in data from the ERP, so order number, et cetera, et cetera, et cetera. And then we built namespaces for compliance. So ISA 55001, this is a JSON payload that contains the compliance record as it's being updated in real time. Okay? And then we have an S88 batch control compliance record that's being updated in real time as we're working through batch control. Okay? And we also happen to have the integration of a series of AI agents. So we have 2 AI agents running and monitoring our process. So you look under line 1, production agents, production agent 1. That payload, the production agent 1 payload, is being published by an AI agent. And so if we look at the data that's in there, I think this is the one that Claude's running. So if I look here, we are predicting cycle time here, and we are using, we're using XGBoost there. Production agent 2, we are using Claude 3 Sonnet. So that's a Claude AI agent. And what you're seeing there is the operator, what the supervisor is typing into the chatbot. Why is line 1 rejecting so many parts today? But what's important to understand is what you see over here on the left-hand side is what we refer to as a unified namespace architecture. Okay, and in this architecture, I'm going to go show you guys what we did at Prove It. So this is this is a virtual factory that is an actual copy of a manufacturer in Dallas. We actually recorded the unified namespace of a flexible packager in Dallas, and we created a virtual factory for Prove It earlier this year. And then 36 vendors all plugged into this unified namespace, consumed the data, and they built some solution. You can see the WinCC OA solution out here. I think it's actually over here on this side, right? You can see what they built with this data on the screen over by the stairs, okay? But also, all of the vendors published back into the unified namespace. So you'll notice you have Machine Metrics, you have Rosline Associates, Tatsoft, Eucodyne, Maintenex, and Atanta Analytics, who's here. I don't know if they're in the room, but Atanta Analytics is here. And that is, you see Atanta's data? That is, they built a solution that consumed the virtual factory. They built a solution and then published back the data that they generated into the UNS. So all of the vendors were able to see what it is all the other vendors were doing. That's UNS. Okay, that's unified namespace. It's an architecture. Okay, how many of you are building your solutions on an architecture like this? All right, tell me why it shouldn't be done this way. I mean, I am all ears, by the way. I would love.
I would like to learn more.
Okay.
That's all it is.
So there is an inherent problem with what we see in energy is all the names are customs. I think that you come to the name and this is what you decide. And
Yes.
I think the big point that everybody should talk about the same. And in energy we have this with the 6150, 6125. We try to go and say, okay, active power is the same for everyone, and reactive power and voltage, so we don't have someone calling it A and someone calling it B, and it's at the end the same kind of data.
So what are the biggest problems with unified namespace? All right, here are the biggest problems. You eventually get to a point where managing naming standards has to be a priority. The advantage of unified namespace is that any of you can start building solutions with I am a firm believer in the power of the citizen developer. Okay, that is, the smartest people in any organization are the people who work on the plant floor. One of the greatest things my father ever told me, I have an IQ of 152. I'm a member of Mensa. I graduated second in my high school class. I graduated summa cum laude, third in my engineering class. I'm a smart guy. I'm a smart guy, okay? My father told me after I graduated from college, he came to my graduation party, patted me on the back, and he said, Walker, I'm really proud of you, but nothing you learned in college makes a bit of difference in the real world. You know nothing. And so when you start your job on Monday, I want you to find someone who's been there for 30 years, and I want you to learn everything they know and keep your mouth shut. He said, because I promise you, the other engineers you graduated with aren't going to do that. They're going to come in thinking they're smarter than everyone else. And so I had an advantage. I really respect my father. I went in and I did keep my mouth shut. And what I observed was that the smartest people in any organization are the ones who do the work. They don't talk the way we do. They haven't read the books we read, but they know what the problems are and they know what the solution is. And our job as engineers is to unlock the potential in those minds. It is, what is the actual problem? Here's an example. I used unified namespace to solve this problem. I was visiting an oil and gas customer. And one of the things that I like to do is I like to get a room full of people. And when I start, I say, I want you guys to be thinking about a problem that you've had for a week, a month, a year, 10 years in your job function you have not been able to solve. And it doesn't have to be technically related. I don't care what the problem is. You tell me, what is the thing that drives you crazy? And then I went and did my presentation, and at the end I went around the room and they came to this guy who's a lease operator. Anybody who here knows oil and gas? All right, so a lease operator is, in oil production, you'll have wells that cover hundreds of square miles, okay? And so you'll have a lease operator who's responsible for, say, 60 sites. And he'll visit 20 sites each day. He'll drive in his truck and visit 20 sites each day. So every fourth day, he's getting back around to the ones he went to 3 days ago. But he also has remote alarms that he gets text messages on, high tank alarms, so he has to like intervene on an environmental event. I get around to a lease operator, so most of the people in the room are executives. I always insist that operations people are there, someone with a hard hat, somebody who drops F-bombs. I'm looking for that guy, okay? And he says, here's the problem I have. I go, great. He goes, I have all this technology. I got this text message at 2, and he shows me the alarm. I got this text message at 2 o'clock in the morning on Sunday night, okay? Or Saturday night, 2 o'clock in the morning, Sunday morning. And it says I got a high tank alarm out at this location. So I dispatch a tanker to go pump that tank down because the EPA is going to charge us tens of thousands of dollars in fines if we have a spill. And that tanker goes out there on triple time because it's a Sunday. Okay? He gets out there and he calls me and he says, "Hey man, I could have come out here Wednesday." He's like, the inflow coming into the tank is so slow. We have 3 or 4 more days. He goes, I don't need to know how much fluid's in the tank. I need to know how much time I have left in the tank. He said, I need time in tank. And all the executives in the room were like, wow, that's fucking brilliant. And so it took me 10 minutes to build a functional namespace. I already had volume of the tank. I already had volume. I had the height of the alarm. I had the height of the switch. I had inflow and I had outflow. That's all I needed to calculate time in tank. Took 10 minutes. I wrote a function in a unified namespace that gave him time in tank. And then I had another platform consume that data. So it became a tag inside that platform. And then I generated alarms off of the time in tank. 10-minute solution on a common infrastructure. And if we didn't already have all the data in a unified namespace, the volume, okay, the height of the tank, the inflow, outflow, I would have had to start from scratch to build that solution, and they would have had to spend $20,000 or something instead of 10 minutes, no charge, okay? All right, let me make sure I've covered everything. I've got 15 minutes, right?
What do you apply customers for the data storage? So we have no historical data, right? Only if you listen all the time to the broker, you could build up the history.
Yep.
What typically do you apply? A tool like Ignition or WinCC or just plugging in a SQL database or whatever?
So in a UNS generally, so I should have showed you a distributed architecture. So if you look at a reference architecture of a typical manufacturer that's using unified namespaces as their architecture, they're going to end up with 3 MQTT brokers that are in sync with one another. So which broker I publish and consume from is going to be a function of which layer of the stack I'm in. So you're going to have a broker on the edge, you're going to have a broker at the plant level, and they're going to have a broker in the cloud, an enterprise broker. They will all be synced together, so I could subscribe to any one of those endpoints and see the full UNS, unless I'm restricted by my role, and then I can only see what it is I'm allowed to see, okay? And I can only publish to what it is I'm allowed to publish to, all right? So generally, in the lower level, we're using something like InfluxDB, time-based, timescale, Canary Labs Historian. Sometimes we're using Ignition's Historian. That's not very common, but we're using some time series database on the edge for sensor data. At the plant level, we're probably doing the same thing. But when we get to the enterprise level, we're connecting a node to the unified namespace, and we're mapping every MQTT topic to a Kafka stream. So we go MQTT to Kafka stream, and then we stream into a data warehouse or a data lake. My preference is to publish into BigQuery. I'm a big Google Cloud Services fan now. publish into BigQuery, and then use Looker Studio Pro for any of my time series analytics. The reason why is Google BigQuery does dimensional. It's very important at the enterprise database, at the enterprise level, to store time series dimensionally. So you must have tables within tables, arrays within tables.
Columns.
Yes. So out on the edge, you generally don't see that. And it's traditional time series, you don't see that.
That's
Yeah.
no problem with time scaling need.
Yeah. But Kafka is, the beauty of Kafka is that Kafka can take this, a unified namespace, and can literally historize the whole name. So I could literally replay back. It literally can turn an entire UNS into a time series database. So then I can look at the whole history in context. All right, I did the demo. I showed you Virtual Factory. The last thing I want to do is just show you a case study, but I'll answer questions first.
I'm sorry, I'm not technical, but the archiving you are doing, is it data consuming? It means if you have to, you store the full semantic of it, it means you have a lot of data consumption.
Yep.
It's big, it's not,
Yeah, we use topic aliases.
yeah.
So instead of storing topic forward slash topic, we have an alias for that big long string. Yep.
Are you using the Sparkplug for that?
So I left Sparkplug out. So I'll mention Sparkplug because you brought it up. So I left Spark. So Sparkplug is a standard for MQTT. That's really, it's an industrial standard, and it's designed. If I wanted to do process control over MQTT, messaging queue, transport telemetry, I would use Sparkplug because it contains all of the error checking that native MQTT does not care. I mean, MQTT is the protocol that Facebook Messenger is built on. Like iMessenger, if you look, when you can see the ellipses when someone's typing, right, that didn't exist until MQTT was invented, because it's MQTT that's giving the state. You're publishing the state while you're typing into a broker, and then it's showing the ellipses. So yeah, but I use Sparkplug for device-centric stuff, so process control, which go ahead.
Yeah, because you say that you're using RLS, how do you like inform about what is the meaning?
You
have a birth message, like in Traverse, the first time you connect, you give all the two names,
But-
and then afterwards.
But MQTT 5 supports aliasing now.
Okay.
So not 3.1.1 does not, MQTT 5 does.
Okay, part
Yep.
of it.
Yes.
Yeah,
Yep.
In the Sparkplug definition, the topic is already organized in a certain manner. Is this completely aligned with the UNS way of naming things, and don't you have name clashes and topic?
We don't have name clashes, but what we have is, if we want to, the issue that we have with Sparkplug is when Arlen and Wes wrote the specification, they just arbitrarily picked group and device and node. So you have these 3 levels basically in a Sparkplug. So what we do is we concatenate levels. So let's say I need 4 levels, but I only have 3 to define. So in the group ID, I will concatenate. I'll go level / level in the group ID, and then I'll have the client parse the /. It's a workaround. It's not elegant. It's not, but it's a workaround. What I generally do, and I want to encourage, for those of you who don't work with MQTT yet, but if you're going to in the future, I use Sparkplug only for device-centric payloads. So that is, I'm going to package something on a device. Like I have a S7 1200, okay? I have a Siemens S7 1200. I am going to make that a device, an edge node, and all the topics are going to be packaged together and then published to a group device node ID. And so what's happening is I'm publishing a birth message that says, here are all the topics, and there's no change in the topics. And then I'm just going to be publishing. I compress them, I encode them, and use Google Protobuf, and then you decode them when they get back to the broker. I would strongly encourage you to only use Sparkplug for device-centric communications. Yeah, go ahead.
Yeah, I have a question. In process factories, which is your strategy for the raw data collection? I try to explain you better. Normally in process, even if the customer has a defined PLC,
Yep.
has 3, 4, 5 different vendors.
Yep.
No, because it's typical to have machines. So which is your strategy to recollect the raw data?
So raw data, you will notice in my namespace.
Raw data, you know, from machines.
Yeah. So you'll notice. So let's look at this production line right here. All right. So this is a Comexi press. This is an Italian manufactured Comexi press that is all Siemens motion control, DH445 motion controllers. Okay. So this is all Siemens. If I go to press 103 and I go to MQTT, which is actually the edge, we are collecting any topic that begins with a lowercase letter here. That is coming directly from the motion controller. So generally what we do is we have an edge namespace where we collect all the raw events. So the PLC publishes into edge, raw, not contextualized at all, just literally every friggin' tag. Okay, so you got every tag, every transition in edge. And then we use clients or an IIoT platform like WinCC OA, which I'll show you later in the afternoon, how we're gonna take stuff from this namespace. We're going to bring it in, create data points and data types inside of WinCC OA, and then using Node Red, we're going to add to it and publish back to the broker.
Where you are doing the buffer, I mean, it's normal in the factory that you lost the connection with a certain machine for a period.
Yep.
So your OEE calculation, when you have this
Yep.
no data for a period, is wrong.
Yep.
So the buffer will be done in your suggestion in the PLC level?
So there's two things going on here. All right. You have future state of a manufacturing facility. What is future state? So future state is all of the PLCs will support natively your technology. That's future state. So if you look at Omron, N series PLCs, Opto22, Groove App, I mean, there's a whole host of PLCs that support the technology today natively. So let's say I'm using an Opto22 Groove Epic. Well, I'm going to be using store and forward on the PLC. So the PLC will buffer all those messages and then stream them up into the broker upon reconnection. But let's say I'm using a Siemens S7 1200. I have to have a gateway between the PLC and the broker that's going to do the store and forward for me, the buffering for me. But that's current state.
PLC concentrator.
Also, we would also work with the 1200 to store in the data blocks and so on, and then you could do that.
Correct, and also there's a block. Some guy wrote a block in Brazil. I think now Siemens owns it. That will handle the buffering inside the PLC as well.
Yeah, but normally your machine builder has not done that. The buffer.
So remember, it's not where we are. It's where we're going. And there's a transitional. Everything. One of the beauties of unified namespace is that I can decouple old technology, put in new technology, and publish exactly the same way I was publishing with old technology, and the consumers will never know the difference. But yes, let's say I've got a PLC. I want that PLC to publish up into my broker. First off, most PLCs don't support MQTT out of the box anyway. You're going to have to put a gateway there. The gateway is going to handle the store and forward, the buffering. But you use the fact that you need a gateway as the justification to upgrade your PLC to technology that supports the minimum technical requirements out of the box.
Yeah,
Yep.
but when you're in a as an integrator in a brownfield plant, yeah, and they have all these legacy stuff, and they have machines from different vendors, they will not upgrade their
They will. They'll upgrade in time. There is a period. You're right. In that, remember. Yeah, you remember. Yeah. So the way you solve it now is you do the 3 layers architecture. So I have an edge architecture, I have a plant level, and I have enterprise, and my gateways are on the edge. So a really common with an IoT platform. Say I'm using WinCC OA. WinCC OA is I'm either going to use native drivers or I'm going to connect to an OPC server that's got the native drivers that's already talking to the PLCs. And then I'm going to use WinCC OA to do all the data operations that converts this legacy technology into my UNS architecture. And then WinCC OA is going to publish into the infrastructure, which is what I'll show you. And I'm going to use a simple example because I don't want to. The goal is to teach you guys just enough so that you'll be able to bolt WinCC OA onto a UNS infrastructure and do something with it. That's the goal today.
So as example, so I'm as
Yep.
So I'm the WinCC sales guy in Germany. So if I have that challenge to buffer the data, so I would recommend to use OA on the edge level. But so we have only the store and forward to our backend. So if I store the data in the database, so in the database backend we have the store and forward. But how to connect the data that are now on the historical database back to your unified namespace? So what's your solution?
So it depends on what I'm using. So if I'm using, if I'm in the cloud layer and so I'm using BigQuery for my big data, then I'm using MDE, Manufacturing Data Engine, to consume from BigQuery and publish it back into the broker natively. So that's Litmus automation. So Manufacturing Data Engine by Google Cloud Services is actually Litmus automation. They just white label it. So we use Litmus MDE to query out of BigQuery and publish back into the namespace. If I'm using Canary Labs Historian, we do the same thing. There's already a native connector. So the Canary Labs will consume the UNS as an asset model inside of Canary's Historian. We'll store the historical data, and then we use MQTT Sparkplug or flat MQTT to publish back in. And you're not generally putting historical data in a unified namespace. What you're normally doing is, I may put the last hour of historical data of a specific sensor in a functional namespace. I may have current value of the sensor and the last 30 minutes of the sensor, maybe, and current values coming from the PLC and last 30 minutes is coming from the historian.
You use what, JSON?
Yes, yep. 5 minutes, yep.
Yeah, I have a question. How do you map this in the OPC specification standards? Yeah, in OPCs, you have views and information modeling. Can I assume that this is your information model in the OPC specification standard? Or?
Yeah, so it's similar to, a better way to.
I want to map, I know OPC specification standard with the views, and you can look to the data.
Yep. So this would be a view in OPC-UA. And the information model would be under MQTT. That would be an information, or like role information would be an information model in OPC-UA. And the semantic hierarchy would be the OPC-UA view. Okay?
I have a question. Sparkplug allows you to, on the fly, add new devices and create new word messages that this device is now there. How do you cope that some metrics above are depending on the devices being present, and how to notify? You
use the death message as the inhibit. So stop read on new death message until I see new birth message from the client.
Kind of cascading mechanism. You can calculate, an agent can calculate stuff based on those equipments, and somebody else is using your information to do other stuff, but he is not aware of the fact that he needs to look at these birth messages. If somebody else did that, there's some kind of cascading effect.
Yeah, so one of the things that...
Understand how the system is coping with that.
So something that's missing in here, and the reason why it's not in there is because it's confusing when people who don't build UNS are looking at it, so we leave it out. It's Adam, right? Yeah, so Adam and I were talking about this earlier. He was asking a question about complex data types, but the answer is the same for you. So one of the other payloads that we publish in a functional namespace is the definition for the client on how the client is supposed to consume it. It's the requirements for the consumption. So there will be a payload that is client requirement in camel case, and it'll say, here are the topics that you're supposed, key value pairs that you're supposed to incorporate into your logic. And then sometimes it's just a string that with a description. Make sure you do this when consuming this model, this information model. Yep.
You're an excellent trainer.
Thank you.
What is your actual sales model? Like, what do you sell?
Well, we don't sell anything. We solve problems and then we monetize it. I'm happy to explain it if you want. How many minutes I got? 1 minute? Here, I'll show you how we do this. So I just sold my integrator in September, but this is what we do. We do free content, and it creates a flywheel. We produce free content on YouTube and LinkedIn. And the idea is to educate. Somebody will reach out to me, ask a question, and I'll go, oh, and I'll just answer it. And people just watch videos and they stay in this flywheel. And is it valuable? So if watching free content is valuable, then they'll just keep watching it over and over and over again. They'll watch every video. And eventually, somebody will go, I have a problem I think they can help me solve. So then they reach out, they contact us, and then every single day we get between 15 and 20 warm leads in our CRM, people just reaching out to us every single day. And then we have a team, we have a girl who researches everybody, reaches out to them and says, well, hey, what's your problem that you have? Why is it you reached out to us? Why did you watch this video? Why did you whatever? And it helps us produce more content. And then if their problem is a problem we can solve, like for example, Belden, so Belden, the wire maker, they did like a mini course, and when we reached out to them, they were like, we want you to train our entire workforce. Will you create a training plan for us? We'll pay you 6 figures to build an entire video plan with all the quizzes and everything, and we want every single employee in our company. We did the same thing for, what was it? Magna, and what was it? Cosmet First. We have training plans where we've trained in 130,000 employee organizations. At IIoT.University, we have 14,000 students. So there are 14,000 students globally who take our educational products. Of all of our students, 1,000 of them are paid. So about 1,000 students have paid for Mastermind or one of the big workshops that require a lot of effort. Anything that I can teach in 45 minutes or less, we give away for free, always. But if it's going to require me 40 hours of development, then we come up with some package and we sell it at IIoT.University. I do a lot of this. Like my speaking fee here is really small. It's more expensive to fly me here than it is anything. And then I do a lot of consulting for businesses now. So companies hire me to come in. The team arranges it. And then I come in and we evaluate the business top to bottom and we tell them, hey, this is how you need to change your go-to-market strategy. If you look at HiBite, Litmus, Tatsoft, these companies that all added in 2-hour resettable licenses where you can download their software for free and use it for 2 hours, that was our recommendation to all of them. So that's kind of what we do. But I mean, I'm worth 30-something million now. I mean, I think I'm 33 million. I don't have to work at all. I'd never have to work ever again. I am doing this because I want my life to mean something. Like when I die, I want people to say that I left a positive impact on the world. And the positive impact I want to leave on the world is I want to grow the middle class in the United States. That's what I want to do. I believe that all of there was a dude who came up to me yesterday and he was really mad at me. He was from Finland, guy. And he called me a jerk and he said that I was like President Trump. You're President Trump, And I believe that type of divisiveness, him being angry at me, is a function of the decline of the middle class. And the fewer and fewer people we have in the middle class, the more discontent we have in our societies, the more conflict we have among one another. My goal is to help grow the middle class. So the only things we charge for are the things that, I don't even know how much money we make. I tell the team, it's your job to keep us in business. Yeah, go ahead.
Last question?
Yeah,
You mentioned before,
and then you.
I'm sorry.
Yep.
You mentioned before you asked a client 3 questions.
Yeah.
What are you good in? What are you bad in? What do you miss?
What's missing? Yeah.
What's missing? So may I ask you what you're bad in?
I'm very bad at considering people's feelings when I'm talking. So I don't think, I think about the problem. So, and I believe you have to own your feelings. And so one of my shortcomings is I'm not very considerate. And so I surround myself with people who are considerate. And one of the reason Vaughn is always with me, no one has ever said, I don't like Vaughn, ever. Literally nobody has ever said, I can't stand that guy. So the reason he's with me is because I may not think about your feelings when we're talking. I may say something to you that offends you, and I don't mean to offend you. I'm just being very blunt. Another thing I'm not good at is remembering names. So I'm terrible at names. Yeah.
train the Siemens employees?
Uh,
Is there a training course
so I,
coming up?
can I share? Yeah, so we've been working with ETM and Siemens on how they should go about doing training, both for customers and internally, and the conversations have been very fruitful. Yeah, so I believe, yeah.
Stickers?
Say that again?
Stickers?
No, we didn't. We don't. I don't do the commercials at all. In fact, the only reason I know how much Belden paid was because Belden told me accidentally in a meeting. I didn't know. I'm actually, and I want to recommend that if you're thinking about going into business for yourself, and you're going to be an executive leader, you have to separate yourself from the money. You have to be strategy and mission, and you have to pay someone to keep you in business. You can't be close to the money, because then you'll make short-term decisions, and that's not how you get to where you're trying to go. You got to do long-term planning. Yep.
How big was your system integration company when you sold it?
So the market value was 73 million, and I sold it to the employees for 33. So it was one of the top 10. One of the beauties of UNS, you integrators, we never lost against another integrator, ever. We beat every single integrator. Never. We never once lost a head-to-head in 10 years of business. Not once.
The reason for that?
Because if you looked at our bids, our bid would be, we came up with a strategy. We would land 3 projects at the exact same time, and our senior engineers would go, here are the tasks that are congruent across those 3 projects. So here are the things I have to do on all 3. And so we would schedule so that when I do that task, I'm doing it for 3 customers at the same time. So when you guys are struggling to get 80% or 90% utilization, we have engineers that regularly were at 150% utilization. And they weren't working 80 hours a week. The key was with UNS, with the UNS architecture, I could build a feature one time for 3 clients, as long as I scheduled them correctly. That was the key. And I just taught that in a mastermind, and I didn't think that was going to be such a huge deal, but it was a unbelievable, the feedback we got from the students was overwhelming. So I'm sorry I kept you guys a little long, but we'll be back here at 1 o'clock, and we're gonna do the WinCC OA integration to a UNS.